In this problem, we're going to see what happens when we use different state assignments. So for the first one, we're given the state assignments A is 0, 0, B 0, 1, C 1, 0, and D 1, 1. So first we'll just redraw the table using those. And the output doesn't change, so that stays the way it is. And I'm going to label these Q1, Q2. So I was using Y earlier. I think the book uses Y. So Q1, Q2, so that's 0, 0, and B was 0, 1, and C is 1, 0, and D is 1, 1. And then I'll replace all of my A's with 0, 0s. And my B's with 0, 1. And C with 1, 0. And D with 1, 1. And this is Q1 star, Q2 star, Q1 star, Q2 star. So let's figure out what our circuits are going to look like. So I'll start by doing Q1 star. And my inputs are Q1, Q2, and also W. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So W equals 0. Now this is Q1 star, so that's just this first column. So in this first column, in the first section here, corresponds with W equals 0, so the first row of my Carnot map. So 0, 0 is 0, 0, 1 is 0, 1, 0 is 1, and 1, 1 is 1. And then when W is 1, 0, 0 is 1, 0, 1 is 1, 1, 0 is 0, and 1, 1 is 0. So Q1 star is this top right circle has Q1 equaling to 1 and W equal to 0, so it's Q1 W bar. This bottom left circle has Q1 equal to 0 and W equal to 1, so that's Q1 bar W. So you might notice that that is the same as the exclusive OR of Q1 and W, so we can do that with one gate. Okay, so now let's check Q2 star. So this is Q2 star. Q1, Q2, and W. So now we're looking at the second column. We can see for W equals 0, it's the same as Q1. And for W equals 1, for 0, 0, it's 0. For 0, 1, it's 1. For 1, 0, it's 0. And for 1, 1, it's 1. So this equals, so that's Q1 W bar, just like before, plus, and now this one has Q2 equaling 1 and W equaling 1. So it's Q1 bar and Q2 W. And alright, now we need to do our output. So W, this is our output W, Z, our output Z. So Q1, Q2, and W, 0, 0, 0, 1, 1, 1, 1, 0, and 0, and 1. And when W is 0, our output was always 0. And when W was 1, our output was 1 for 0, 0, and 1, 0. So I can grab those like that. So Z equals, let's see, that has Q2 equaling 0 and W equaling 1. So here's my circuit. I will have D1, Q1, and D2, Q2, and I have my input was W, and Q1 was Q1 exclusive OR W. So I have an exclusive OR, and it's the exclusive OR of Q1 and W. Q2 was Q1 W bar or Q2 W. So I've got an AND with an OR. So it was Q1 W bar. So here's my Q1. And W bar. So put a little NOT gate in there. And the other one was Q2 W. And then it's the OR of those. And then Z was Q2 bar W. So here's W. Here's Q2 bar. And that will be Z. Okay, now this is what our circuit looks like if we use the state assignment that was given up above. I'm just checking my notes to see if this matches what I have in the notes, and it looks good. Yep. Okay, so now we're going to do the same finite state machine, but this time we're going to use a one-hot assignment. So one-hot assignment means that in each case only one bit is 1. So this one we had 4 states, and so we used 2 to the 2 equals 4, so we used 2 flip-flops. This one we're going to use 4 flip-flops. Okay, so here's how our table will look. So this is our present state, and we'll call it okay. So I'm just going with what I have: Q1, Q2, Q3, Q4, and our next state. W equals 0, W equals 1. So Q1 star, Q2 star, Q3 star, Q4 star. Now there's no rule about, how, what do you call these? Do it end in what order? Do I do 0, 1, 2, 3? Do I do 3, 2, 1, 0? You either go with what's given if the problem is given, or you just decide for yourself. Okay, so A is 0, 0, 0, 1. B is 0, 0, 1, 0, C is 0, 1, 0, 0, and D is 1, 0, 0, 0. That's what's called one hot. Okay, now A, 0, 0, 0, 1, 0, 0, 0, 1, and then we have D, 1, 0, 0, 0, 1, 0, 0, 0, and C, 0, 1, 0, 0, D, 1, 0, 0, 0, A, 0, 0, 0, 1, and B, 0, 0, 1, 0, and our output 0, 0, 0, 0, 1, 0, 1, 0. Okay, now for these, you're not going to want to do a full-fledged Carnot map, a 5-variable Carnot map. Usually with these, you can do it by examination. You can look at it and you can figure out what it's going to be. So let's look at Q1 star. So Q1 star, that's this first column here and the first column here. So you'll notice when W is 0, Q1 star is 1. Here and here, so I can say W bar Q1, that's from this one, or W bar Q2. And now I can look over here, or W Q3. Okay, so because I have so many unused states, if I were to do them all out, I'd have so many don't cares, and it would collapse into these anyway. So that is Q1 star. So Q2 star, that's this column and this column. Well, you can see the only time we get a 1 for Q2 star is when W is 1 and Q4 is 1. So the nice thing with one hot, the reason this is working, is the only time Q4 is 1 is in this row. The only time Q2 is 1 is in this row, and that's why this is working. So Q3 star, let's see, so there are all zeros here, and we have a 1 there, so that's W Q1. And Q4 star is, alright, so here in this one, when W is 0, we would have W bar Q4 or W bar Q3 or W Q2. And let's see about Z. What does Z equal? So Z equals W Q4 or W Q2. And I can write that as W Q4 or Q2. It uses one less gate if I do it that way. Similarly, let's see, this one, if I write it W bar Q4 plus Q3 plus W Q2, I think that uses one less gate. And this one, W bar Q1 or Q2 plus W Q3. Alright, and then you can draw the circuit. So circuit's pretty easy to draw, so I'll just let you do that.